Something this immense, this layered, this old, should have a middle, a quiet coordinate, a hidden throne, a location that could be pointed to and named as the place where everything truly begins. Strip away the stars, the dust, the galaxies, the darkness between them, and intuition still reaches for the same expectation. There must be some secret core behind it all, some central chamber of reality, some point that the universe is arranged around. And yet, modern cosmology delivers a far stranger answer than emptiness. It says that the place most expected to exist is not merely hard to find. It is not distant. It is not concealed behind clouds of gas, or lost beyond the reach of telescopes, or buried in some ancient era now gone. It is absent. The universe, in the deepest sense available to current physics, does not come with a special central location.
The center is not merely unobserved. It is not predicted. It is not just beyond the horizon. It is absent from the underlying large-scale description. The place intuition expects most strongly is the place the universe does not have. That sounds at first like a trick of language, then like a technical detail. Then, if the idea is followed far enough, it begins to feel like a crack opening under ordinary thought. Vast things are supposed to have middles. Real things are supposed to be somewhere. Events are supposed to happen at places. Explosions are supposed to burst outward from points. Expansion is supposed to spread into emptiness around it. If every galaxy is moving away from every other galaxy, then surely something must mark the original launch site. But one by one, those expectations begin to fail. The universe is not only larger than instinct expects, it is shaped by rules that make instinct unreliable.
The ideas that work beautifully for houses, stones, trees, cities, planets, even solar systems, begin to blur when applied to the cosmos as a whole. The mind keeps trying to picture the universe as an object among other objects, something sitting in a larger emptiness, something with sides, a surface, a middle, perhaps a direction that points outward from its core. That image is powerful. It is also wrong, and the full weight of that wrongness is hard to feel all at once. The first reaction is usually to replace one center with another. If Earth is not central, perhaps the Sun is. If not the Sun, then the Milky Way. If not the Milky Way, then the region around the Big Bang. If the universe expanded, then perhaps there must be some ancient place from which the whole thing spread, the way smoke spreads from a fire or shrapnel from a blast.
But the more carefully the evidence is assembled, the more unsettling the result becomes. There is no single outward direction from the Big Bang, no favored location left over from the beginning, no cosmic marker saying, "This is where it all started, and here is how far everything has traveled since." The beginning was not a point in space from which matter shot outward into pre-existing emptiness. The beginning, as modern cosmology understands it, was a state in which space itself was different everywhere. That change happened not at one place in the universe, but throughout the universe, everywhere. That word is easy to say and hard to hold on to, yet it is the key to the whole idea. The Big Bang was not like lighting a fuse in one corner of a dark room. It was not even like setting off a charge at the center of a sphere. It was closer to a change in the room itself, except even that analogy quietly smuggles in a larger surrounding space. The actual picture is stranger. Space was not a stage on which the event occurred. Space was part of the event. Once that is understood,
Another puzzle immediately appears. If there is no center, why does the universe seem centered on whoever looks at it? Why does every observer see distant galaxies receding in all directions? Why does every observer occupy the middle of their own observable region? Why does the sky, at the grandest scales, keep presenting itself as if the observer sits in a privileged place? The answer turns out to be one of the most beautiful in cosmology. The universe can look centered on every observer without making any observer special. What appears to be a contradiction is actually a clue. It points toward a geometry of expansion in which no single galaxy holds the favored seat, and yet each one sees the same general pattern written across the deep sky. That is not a poetic exaggeration. It is a measurable feature of reality. And once it settles in, the old image of a cosmic middle starts to feel less like common sense and more like a habit inherited from smaller worlds. If ideas like this are the reason space never quite lets go of the mind, subscribe now. There is a certain kind of wonder that arrives only when familiar intuition finally gives way, and these are the boundaries where that happens. The expectation of a middle begins early. It is trained into perception long before anyone hears the word cosmology. Ordinary objects have centers. A ball has one. A table has a rough middle. A room has a point that feels central. A country can be described in terms of its center.
A target has a bullseye. Even when an object is irregular, thought still reaches for some balancing point, some place that organizes the whole. Human life is conducted among finite things, and finite things often present themselves through boundaries. Once a thing has a boundary, the mind naturally imagines an interior structure. Once an interior exists, the center seems almost unavoidable. This is not a flaw in thought. It is one of the mind's most effective shortcuts. Centers help with orientation, building, throwing, measuring, navigating, arranging. They help define symmetry. They allow motion to be described. They allow objects to be balanced, spun, divided, mapped. Everyday life would be poorer without the concept. And experience strengthens the habit. Villages have centers. Storms have eyes. Wheels turn around hubs. Fruits have cores. Planets have interiors. Living bodies organize around internal axes and structural balance. Even something as simple as a puddle settling on a surface tends to draw the eye toward a middle region.
The world seems full of holes that gather themselves around some kind of central condition. Then astronomy arrives and begins stripping these centers away. At first, the shift is local. Earth feels central to ordinary perception. The sun rises, the stars wheel overhead, the heavens appear to turn around the observer. For long stretches of human history, it seemed entirely natural to imagine that the ground underfoot held the privileged place. Then the Copernican shift broke that image. Earth became one planet among others, circling an ordinary star. But the pattern did not stop there. The sun, once elevated, became a star among hundreds of billions in the Milky Way. The Milky Way, once treated as the whole of creation by default, became one galaxy among many. Then the known number of galaxies grew from the thousands to the millions, then the millions to the billions, and now the estimated count in the observable universe reaches into astonishing figures, even after revisions in how such counts are made. Everywhere telescopes looked, more structure appeared. Clusters, superclusters, filaments, walls, voids. The cosmos expanded outward not only in size, but in humility. Each time a larger scale came into view, the old center dissolved. That history can make the current idea sound like just one more step in a familiar pattern. But saying the universe has no center is not simply another insult to human pride, not merely a larger version of the claim that Earth is not special. It is more radical than that. It is not saying that the center exists elsewhere and was wrongly assigned.
It is saying that the kind of center intuition expects may not apply to the universe at all. That is where the universe stops behaving like intuition expects. A solar system can have a clear dynamical center. A galaxy can have a rough central bulge, and often a supermassive black hole near its core.
A planet has a center of mass. These are not illusions. They are real structural features of bounded systems. Such systems exist within larger contexts. Their geometry, formation, and motion can often be described relative to internal reference points. The universe as a whole does not obviously fit that template. The first temptation is to ignore the words "as a whole." Human thought is far more comfortable with partial pictures. It wants to imagine the universe as a giant object that could, in principle, be viewed from outside, like a glowing sphere hanging in darkness. Once that mental image takes hold, the rest follows automatically. If it is a sphere, it has a center. If it expanded, the center should remain identifiable. If galaxies rush away from one another, then perhaps they are fragments from some ancient detonation.
This image is persuasive not only visually, but emotionally. It offers a hidden architecture behind the confusion. Somewhere there is a place where the early universe was once concentrated, and current reality is just the aftermath of being flung outward from it. Yet nearly every part of that picture imports assumptions from the wrong scale. The universe is not known to be embedded in a larger ordinary space where an external observer could stand and look back at it. Space on cosmic scales is not simply an empty container waiting to be filled. Galaxies are not debris moving through static emptiness away from a central blast point in the manner of shrapnel. And the Big Bang, despite the name, was not an explosion in the everyday sense. That last point is where many confusions begin. The phrase Big Bang is vivid, memorable, and deeply misleading if left uncorrected. It calls up an image of compression, ignition, eruption, something dense sitting somewhere, then suddenly bursting apart.
That is how bangs work in familiar life. A firecracker explodes at a point in space. A bomb detonates in a room. A star can explode and throw material outward from its location. In every case, the event happens somewhere, and the surrounding space remains in place while matter and energy move through it. The cosmic beginning is not like that. The early universe was indeed hot and dense. Those words are accurate as far as they go. But the hot, dense state was not confined to one little region inside a larger, quiet emptiness. It was the state of the universe itself, as far as the observable evidence can trace it. There was no privileged external vacuum into which it detonated. There was no surrounding room whose walls might have heard the blast. There was no central point in otherwise ordinary space from which the cosmos began spreading.
The universe did not start by expanding into space. Space itself was part of the expansion. That is a difficult sentence, partly due to its content and partly due to language. Everyday speech treats space like a container. A box can be empty or full. A jar can hold marbles. A room can have furniture placed inside it. Once space is mentally cast as a grand version of that sort of emptiness, the phrase "space expanding" sounds impossible. How can emptiness stretch? How can there be more room if room is the thing doing the changing? General relativity opened a path through that confusion by replacing the old image of space as a passive stage with a more active geometric structure. In Einstein's picture, space and time are woven together in a dynamic fabric shaped by energy, momentum, and mass.
That phrase, fabric of space-time, can become its own source of misconceptions, but it captures at least one essential point. Geometry is not fixed in advance. Distances on cosmic scales can change over time as part of the universe's evolution. This is not a visual trick. It is built into the equations that describe large-scale cosmic behavior. When astronomers observe distant galaxies, their light is stretched toward longer wavelengths. This redshift can be understood on the largest scales as a sign that the universe has expanded while the light was traveling. The farther away a galaxy is, the greater its redshift tends to be. This relation, first established through observations in the early 20th century and refined ever since, reveals a broad pattern. Space between distant galaxies has grown. Nothing in that sentence requires a central origin point in ordinary space. In fact, once the equations are taken seriously, the demand for such a point becomes less necessary.
If space itself changes everywhere, then all sufficiently distant regions separate from one another over time without needing to fly outward from one privileged place. A useful way to say it is that the universe expands uniformly on large scales, not from a center, but through its own geometry. At first, that still feels evasive. Uniform relative to what? Everywhere compared with where? If expansion is happening, what marks the still point? But this question quietly assumes that expansion must resemble motion through a background. It assumes there must be a kind of cosmic floor that stays put while everything else glides across it. That image is exactly what the cosmological picture asks the mind to surrender. Take a simpler case. Imagine points painted on the surface of a balloon. Not the inside of the balloon, not the air around it, only the two-dimensional surface itself.
As the balloon inflates, each point sees all sufficiently distant points moving away. The farther apart 2 points are, the faster the separation grows. No point on the surface needs to be the center of this expansion. The center of the balloon exists only in the higher dimensional space into which the balloon is embedded, not in the two-dimensional world confined to the surface. This analogy is famous for a reason. It captures something essential, yet it must be handled with care. Its strength lies in showing how expansion can occur without any point on the expanding space being the center. If beings lived only on the surface and had no access to the higher dimensional room, they would describe increasing distances between points while finding no central location on their own world. Every location would observe the same general pattern. Expansion would be real. A center within their space would not.
Its weakness begins the moment the mind forgets that the balloon is only an analogy. The real universe is not known to be the surface of an expanding sphere in a higher dimensional room. The center of the balloon is not secretly the center of the universe. The rubber surface is not literal space-time. The analogy helps loosen the grip of everyday intuition, but it must not be mistaken for a picture of hidden cosmic furniture. A second analogy helps from a different angle. Imagine raisin bread dough rising in an oven. As the dough expands, each raisin sees the others moving away. More distant raisins recede faster. No raisin occupies a privileged center of the expansion. The growth happens through the dough itself, not through the raisins deciding to fly across the kitchen. Again, the analogy works for a reason. It illustrates how increasing separation can be caused by the expansion of the medium, not by outward motion from a chosen point.
It also suggests why the relation between distance and recession can look similar from many locations at once. And again, it must be limited. Real galaxies are not carried passively by a material dough in quite that literal way. Local gravitational systems do not simply swell with the cosmic expansion. Galaxies, solar systems, planets, atoms remain bound by forces that dominate over the very gentle expansion on those scales.
The raisin bread picture is a teaching tool, not a blueprint. Still, both analogies survive repeated use in cosmology for one central reason. They make it possible to imagine expansion without a center inside the expanding domain. That is the doorway. Once through it, the universe begins to look less like an object and more like a relationship among distances. This change of perspective can feel abstract, so it helps to return to a more direct question.
Why does every observer see distant galaxies moving away in all directions? Why does the sky not reveal a side from which everything is fleeing? Suppose the universe were truly expanding from a central launch point in otherwise static space. In that case, an observer near the center and an observer far from it would not see the same pattern. Directions would matter in an obvious way. On one side, more of the motion would appear outward, on the other, less. The sky would carry a directional asymmetry that marked the underlying geometry. There would be a genuine cosmic gradient pointing away from origin. But on large scales, the universe appears remarkably homogeneous and isotropic. Those words can sound dry, but they describe a profound feature. Homogeneous means that, averaged over vast enough distances, the universe has no strongly preferred places. Isotropic means it has no strongly preferred directions. A universe like that can support a form of expansion that looks broadly the same from any suitably typical location.
This is not a statement that every patch of sky is identical in detail. Clearly it is not. Galaxies cluster, voids open, local structures differ. The Milky Way is not interchangeable with intergalactic emptiness. But once the view is widened enough, the rough uniformity emerges. The cosmic microwave background, that faint afterglow from the early universe, appears nearly the same in every direction, aside from tiny fluctuations and the motion of the observer. Surveys of galaxies reveal structure, yet on the grandest scales, no obvious universal center leaps out. That empirical simplicity is one reason the centerless picture became so compelling. It matches what the sky actually offers. To understand why every observer can witness recession without occupying a special place, it helps to think in terms of ratios and relative growth, rather than in terms of a single blast wave.
In an expanding universe described by the standard cosmological model, the distance between far apart, unbound regions grows according to a scale factor, a quantity that changes with cosmic time. Each region does not need to remember a launch direction from some ancient source. Instead, the very metric used to measure cosmic distances evolves. If the scale factor doubles, sufficiently separated distances double. If it triples, they triple. What any one galaxy sees is not a swarm fleeing from another galaxy's throne, but the consequence of all large-scale separations growing together. Picture a grid drawn on a stretchable sheet. If the sheet expands uniformly, every point becomes more distant from every other point. Choose any point, and it looks as though the rest are moving away. Choose another, and the same remains true. The pattern is built into the geometry, not into the special status of any one location. This is the piece that often feels almost suspicious. It seems as though center has been hidden through clever wording.
But the reason the effect is so universal is that the expansion is not centered on observers at all. It only looks that way from any local standpoint. The observable universe deepens that impression. Every observer in the cosmos is surrounded by a limit, a horizon set by the finite age of the universe and the finite speed of light. Light takes time to travel. Looking farther into space means looking farther into the past.
There is therefore a maximum distance from which light has had time to reach a given observer since the hot early phase from which the cosmic microwave background emerged. This region is the observable universe of that observer. And here, the language itself creates trouble. The phrase "the observable universe" sounds singular, as though there is one fixed bubble with a known center.
In practice, every observer has their own observable universe. Each one is centered on their location, not in the sense of cosmic privilege, but in the simple geometric sense that visibility spreads outward from where the observer happens to be. That is unavoidable. A horizon around an observer will always be centered on the observer. Stand in a foggy field, and visibility extends a certain distance in every direction. The circle of what can be seen is centered on the person standing there. That does not make the person the center of the field. It only reflects the fact that observation proceeds outward from a viewpoint. Cosmic horizons work in a far more profound setting, but the basic logic is similar. The observable universe is not the whole universe. It is the portion from which information has had time to arrive. Move to another galaxy far away, and the observable region changes. Some parts overlap with the former observer's view.
Some do not. Each observer sees a different centered sphere of visibility. This is why the claim, "the universe looks centered on us," must be split into two very different meanings. In one sense, yes, the observable universe is centered on the observer. That is true for anyone, anywhere. In the stronger sense, no. That observational centering does not imply that the observer occupies a special position in the universe as a whole. Confusing those two senses is one of the easiest mistakes to make. The mind hears "centered on us" and jumps toward significance, but the actual meaning is geometric and local. It belongs to the fact that light arrives at a point from surrounding directions, not to the notion that reality itself radiates outward from that point. This becomes clearer once the distinction between the observable universe and the full universe is kept firmly in view.
The observable universe is enormous, roughly defined by the distance light could have traveled to us given cosmic history, while allowing for the expansion of space during that journey. Yet it is still limited. There may be vastly more beyond it. The full universe could be much larger than the observable part. It could be finite in some complex way. It could be infinite. Current observations strongly constrain its large-scale geometry, but do not expose the whole. That ignorance is not a minor footnote. It is central to why certain intuitions remain so difficult to shake. A finite observable patch tempts the mind to imagine that the whole cosmos is a larger version of the same kind of bounded sphere. If what is seen is spherical around the observer, perhaps the totality is also spherical around some hidden point. But the sphere here comes from the horizon of observation, not from the shape of the whole. The difference is like confusing the beam of a flashlight with the shape of the room. This is where ordinary experience can mislead with extraordinary confidence. Human beings are used to seeing partial regions of larger structures, while still assuming the larger structure retains familiar, object-like features. A hill glimpsed through fog belongs to a landscape. A house seen from one corner has walls and center rooms. A forest visible from a clearing has edges somewhere. These assumptions often work. In cosmology, they become dangerous if carried too far. The universe does not have to resemble the finite chunk available to observation. Even if the observable universe is spherical around each observer, the full universe may have no edge in the ordinary sense, and no center in the way a bounded object does. That possibility sounds almost self-contradictory at first. Finite things have edges. Things without edges spread forever. How can a universe be finite yet lack both an edge and a center?
The answer lies in geometry, and geometry can behave in ways that daily intuition rarely needs to confront. A two-dimensional being living on the surface of a sphere can travel forever without encountering an edge, even though the surface area is finite. Such a being would not find a boundary where the world ends. The world would wrap around smoothly, yet the surface would still contain only a finite amount of area. Importantly, the center of the sphere, while meaningful to an outside three-dimensional observer, would not be a point on the two-dimensional world itself. Within the surface, there is no central location corresponding to that external center. That possibility loosens two assumptions at once. First, finiteness does not require an edge within the space being traversed. Second, a space can have global structure without containing an internal center of the type everyday thought expects.
Modern cosmology allows analogous possibilities for three-dimensional space. The full universe could, in principle, be finite yet unbounded, curved in such a way that traveling far enough in a straight line could eventually return an explorer to the starting point, though the exact topology of the real universe remains uncertain and current observations suggest space is very close to flat on observable scales. It could also be infinite and flat. Both broad options remain discussed, though the observable evidence currently favors near flatness without conclusively settling the global question. What does near flatness mean here? Not flat like a sheet of paper sitting in a room. It means that on large observable scales, space does not display strong positive or negative curvature. Parallel lines behave approximately as Euclidean intuition would expect. The angles of enormous cosmic triangles do not appear to deviate dramatically from the familiar sum. But approximately flat in the observable region does not immediately settle the ultimate size or topology of the whole cosmos.
That uncertainty matters. The answer to whether the universe is finite or infinite is still not fully pinned down. But the claim that there is no observed central location does not depend on resolving that ultimate question. An infinite, homogeneous universe has no center in the ordinary sense. A finite but unbounded homogeneous universe can also lack an internal center in the relevant sense. Either way, the disappearance of a privileged middle remains possible. This is a powerful moment in the argument, since it reveals that centerlessness is not just a quirk of one exotic model. It emerges naturally from more than one plausible way reality might be arranged. Another reason the mind resists the idea is that it confuses two very different uses of the word center. One use is practical and local, the center of mass of an object, the center of a galaxy, the center of a circle drawn on a plane. These are meaningful inside systems with particular boundaries or symmetries.
The other use is existential and metaphysical, the center of everything, the place around which the entire universe is ordered. The first is common. The second is the one cosmology undermines. Galaxies have centers. Galaxy clusters can have dense cores. The Milky Way contains a central region and a supermassive black hole known as Sagittarius A star. None of that contradicts the larger claim. These are structures inside the universe, not the organizing middle of the universe itself. This distinction seems obvious once stated, yet it is repeatedly blurred in popular imagination. A spectacular object near the center of a familiar structure feels like a candidate for deeper significance. The center of the Milky Way looks dramatic, crowded, intense. It invites symbolic elevation. But cosmically, it is just one galactic interior among countless others. Even the cosmic microwave background, which fills the sky with ancient radiation from the early universe, does not restore a center.
It offers a frame relative to which motion can be described. By measuring slight temperature differences across the sky, astronomers can infer motion relative to that background. But a preferred frame for describing motion
is not the same as a preferred place in space. A frame is about velocities and observations. A center is about location. The two are not interchangeable. This is an important safeguard against a subtle mistake. Sometimes the existence of a cosmological rest frame is treated as if it secretly reintroduces an absolute center. It does not. Observers can describe themselves as moving relative to the average cosmic expansion and relative to the microwave background. That gives a useful standard of comparison, but it does not identify a unique spot from which the universe expands. To see why, imagine once again the balloon surface. A being on that surface could define a natural sense of rest as moving along with the overall expansion, rather than sliding across the surface.
That would be analogous to being co-moving with the cosmic flow. Yet there would still be no center on the surface. A natural standard of motion does not create a central point where none exists. The language of co-moving coordinates helps here. In cosmology, one often imagines a coordinate grid that expands with the universe. Galaxies not caught in strong local gravitational encounters can remain at roughly fixed co-moving coordinate factor changes. Their proper distances grow, yet they are not thought of as rocketing through static space from a central origin. They are simply carried along by the overall evolution of space-time geometry. This is not a complete description of every motion. Galaxies also have local velocities, known as peculiar velocities, due to nearby gravitational influences. Clusters pull, structures form. Local dynamics complicate the clean, large-scale picture, but averaged over sufficient distances, the Hubble flow emerges, a broad recession pattern tied to expansion itself.
The elegance of this picture is that it makes the same sky available to any typical observer. Not the same in detail, of course, since local neighborhoods differ, but the same in large-scale rule. Wherever an observer stands, distant unbound galaxies recede in the same general way. The law is local in viewpoint, yet universal in form. That fact once shocked the imagination. It still should. There is a deep psychological shift hidden in it. Human thought is accustomed to believing that identical perspectives must imply a common central reference. If every observer sees the world spreading outward around them, then it feels as though reality must be conspiring to flatter each observer with a false center. But physics reveals something stronger and cleaner. Centerlessness can generate exactly that observational symmetry. No conspiracy, no special pleading, just geometry. The abandonment of a cosmic center is part of a larger change in what counts as explanation.
For much of history, explanation often meant locating the privileged position from which order radiates. Temples had centers, kingdoms had capitals, maps had reference points. The heavens, too, were expected to have an organizing middle. Remove the center, and at first, the universe can seem to lose intelligibility. If nothing sits at the middle, what holds the whole together as a whole? What anchors it? But this reaction carries a hidden assumption that order requires hierarchy of place. Cosmology suggests otherwise. Order can be distributed. Structure can arise from laws that apply everywhere. A system need not have a throne room to possess coherence. This is one of the most profound lessons modern physics offers. The universe can be lawful without being arranged around a sacred point. It can be intelligible without being centered on a favored location. Reality does not have to flatter spatial intuition in order to remain comprehensible.
Even so, the old images linger. The Big Bang name keeps pulling thought back toward the image of an explosion. It helps to look at that misconception in slow motion. Imagine a genuine explosion in space. Take a fireworks shell detonating high above the ground. The shell explodes at a point. Fragments fly outward, and as time passes, they become more widely separated. Observers in different locations could reconstruct the center by tracing the motion backward. The surrounding space remains basically unchanged. It is a stage. The fragments move across it. Now compare that with cosmic expansion. In the standard model, galaxies on large scales are not fragments thrown through a static arena from a single position. Rather, the metric describing distances between co-moving regions changes with time. Trace the expansion backward, and distances shrink everywhere. The universe becomes hotter and denser everywhere in the modeled region. There is no need to converge on one spatial point inside the universe.
What is approached in the past is not a location, but a condition. That single distinction dissolves vast amounts of confusion. The Big Bang is better imagined not as a blast at a place, but as an early state through which all places passed. Not a point in the universe, an early phase of the universe. Once phrased that way, the idea that the Big Bang happened everywhere stops sounding like verbal trickery and starts sounding like the only way to say it accurately. Every region of today's large-scale universe, when traced back through the expansion, leads towards a denser, hotter past. Every region emerged from that primordial state. No place can claim to have been closer to the event in the spatial sense, since the event was not located at one spot inside an already existing cosmic room. That claim becomes even clearer when thinking about the cosmic microwave background.
This radiation comes from a time when the universe had cooled enough for atoms to form and light to travel more freely. It is observed in every direction. The radiation reaching any observer today originated from a spherical shell of regions that emitted light long ago. Another observer elsewhere would also see such a shell around their own location. The afterglow is not a picture of looking toward a single central birthplace. It is a view into the universe's early hot phase, seen from whichever location happens to collect the light. If the early universe had truly been concentrated at one point in space, the microwave background would not have the smooth all-sky character it does. The entire structure of observational cosmology would look different. The absence of a center is therefore not a philosophical preference laid on top of vague data. It is deeply tied to how the sky actually appears and how the equations that best describe it are built.
Still, there is room for humility. Cosmology deals with scales so large that complete certainty about the total universe remains out of reach. Observations are always made from one place, at one time, within one observable patch. Assumptions like large-scale homogeneity and isotropy are justified by evidence, but they are still assumptions carried beyond the visible horizon. The standard model succeeds spectacularly within its domain, yet the earliest moments remain partly veiled, and questions about inflation, quantum gravity, and global topology are not closed. But none of that uncertainty resurrects the old central point. If anything, the open questions make the absence of a center even more striking. Across many live possibilities for cosmic structure, the expectation of a privileged middle keeps failing to return. Inflation adds another layer to this. In many cosmological models, a brief phase of extremely rapid expansion occurred very early, smoothing and flattening the observable universe, and helping explain why distant regions share similar properties. Inflation is still an active area of research, with many models and unresolved issues. Yet its broad role in shaping modern cosmological thinking is hard to ignore. If some version of inflation occurred, it strengthens the image of a universe whose observable part became remarkably uniform without requiring a central spatial origin in any ordinary sense. Here again, ordinary language rebels. Rapid expansion sounds like something racing outward.
Yet the inflationary picture, like later cosmic expansion, concerns the behavior of space-time itself. Distances between regions increase extraordinarily fast, not through matter shooting into a surrounding void from a central launch bay, but through the expansion of the metric. The deeper the theory reaches, the less useful the explosion picture becomes. There is also a hidden elegance in the way centerlessness protects the principle that no ordinary location is cosmically favored. This is sometimes associated with the Copernican principle, the idea that Earth and its inhabitants do not occupy a special place in the universe. The principle is not a dogma that every detail must look identical everywhere. It is a guiding refusal to assume privilege without evidence. Modern cosmology extends that refusal in a powerful direction. Not only is Earth not the center, there may be no center to occupy. That is a conceptual leap beyond demotion. It is not merely that the crown was given to someone else. The throne itself may not exist. Ideas like this reshape what it means to ask questions. Where is the center of the universe sounds simple, yet it may be like asking what is north of the North Pole. The grammar is clear, but the underlying concept may not map cleanly onto reality. Certain questions presuppose structures the world does not provide. The history of science is full of such moments. An old question dissolves not when it is answered, but when a better framework shows that its terms were poorly formed.
The universe has no center might be one of those moments. It does not close thought. It redirects thought toward more meaningful questions. How does large-scale geometry evolve? What is the shape and topology of space? What caused the early hot dense phase? How did structure arise? What can horizons conceal? These questions remain rich even after the old demand for a central place fades. The loss of the center is therefore not a subtraction of meaning. It is a correction of category. There is a temptation, once the center disappears, to feel that the universe has become less real, less grounded. If everything expands relative to everything else, if space itself changes, if no single location anchors the whole, then perhaps reality becomes ghostly or vague. Yet the opposite is closer to the truth. The mathematical description becomes sharper. Observations line up more cleanly. The apparent paradoxes shrink once the right framework is used. Meaning was not lost. An old picture was abandoned.
And what replaced it is in many ways more astonishing than the picture it displaced. Think about what the centerless universe implies for the night sky. Every point of light, every galaxy beyond the Milky Way, occupies a location from which the cosmos would also appear to expand around the observer. Somewhere in a galaxy billions of light years away, if there were eyes and instruments looking outward, the same great pattern would emerge. Their observable universe would be centered on them. Their deep past would also glow in microwave light. They too would ask whether they occupy a special place, and the same answer would slowly confront them. No. The appearance of centrality is a built-in feature of observation in an expanding cosmos, not evidence of privilege. That realization carries a strange democratic beauty. Any sufficiently typical observer can stand at the center of what can be seen without standing at the center of what is. And perhaps that is one reason the idea feels so philosophically potent. It touches an old human tension between appearance and structure. The world often presents itself from a privileged first-person view. Each life unfolds from one inward center of experience. The sky arches over a single horizon. Every person feels, at least phenomenologically, located at the middle of their own world. Cosmology does not deny that immediate structure of experience. It simply refuses to scale it up into a metaphysical truth about the universe. That refusal is difficult. It asks the mind to hold two statements together. The universe of observation is centered on the observer. The universe itself is not centered on the observer. Both are true in different senses. The gap between them is where much of the confusion lives.
The deepest ideas in astronomy often begin when a familiar phrase turns out to describe two different realities, and the one that is true is usually the stranger one. It is worth pausing on just how far this shift departs from common imagery. Children draw the sun in the center of the page. Ancient maps place home at the middle. Religious and mythic cosmologies often arrange the world around an axis: mountain, tree, temple, or sacred realm. Even secular imagination tends to build the world outward from a core. This tendency is not random. Centers help create narratives. They orient significance. They answer where things belong. A universe without a center does none of that automatically. It offers no natural royal district, no cosmic capital, no objective middle tier from which hierarchy descends. Yet modern cosmology does not flatten reality into monotony. Structure remains everywhere. Galaxies cluster into webs of enormous scale. Black holes curve space-time. Stars form, burn, die. Chemistry unfolds. Planets gather. Life may emerge. There are centers inside these patterns, local and dynamic, but no sign that the entire universe is built around one of them. The large-scale web of galaxies is especially good at misleading the eye here. When maps of cosmic structure are shown, they often display dense regions, filaments, knots, and huge voids, sometimes centered visually on the Milky Way, simply for the convenience of drawing data from the observer's position. Without care, such images can seem to imply that there really is a middle. But the centering in those maps usually reflects where observations were made, not where the universe itself is organized around. The sky is being plotted from a local vantage point, as all sky surveys must begin somewhere. This highlights a general principle. Many images of the cosmos are viewpoint dependent, yet the underlying physics aims to describe what is not. Confusing the visual format of a map with the ontology of the universe is another easy route toward error.
The same is true of statements like, "the farthest object ever seen." Farthest from whom? Always from the observer making the measurement. Move elsewhere, and the ranking changes. Distances in cosmology can also be defined in multiple ways: co-moving, proper, luminosity, angular diameter, each useful in context, and each capable of producing confusion if treated as a single intuitive distance. Once again, the universe resists the demand to behave like the small world objects that trained human intuition. The absence of a center also reframes the word everywhere. In ordinary life, everywhere usually means every place within a space already imagined. In cosmology, saying the Big Bang happened everywhere means that the early hot dense state was not local to one region within a larger quiet universe. It characterized the whole modeled space. Every co-moving location now accessible to thought was once in that hot dense phase.
This is among the hardest lines to visualize, honestly. The mind keeps asking, everywhere in what? Everywhere compared with where? It wants an exterior backdrop, but the universe may not offer one in any sense relevant to the question. Space is not known to sit inside a larger ordinary container that waits beyond its boundary. Asking what the universe expands into may be another case where grammar outruns ontology.
That does not mean there are no serious speculative ideas involving extra dimensions, multiverses, bubble universes, or embedding structures. There are. Physics contains proposals at those frontiers. But none of them are required to understand why the standard cosmological picture lacks an internal center, and none have yet supplied observationally established evidence that the universe expands into a larger room in the naive, everyday sense. The careful answer remains more restrained. According to the standard large-scale description, the universe is not modeled as expanding into external, ordinary space. The geometry of space itself evolves.
Restraint matters here, since grand cosmic questions invite runaway imagination. It is easy to slide from the honest weirdness of cosmology into decorative mystery. But the true idea is already strange enough without embellishment. Space can expand. All large-scale regions can once have been hotter and denser. Every observer can witness recession without being central. A finite universe can lack an edge. An infinite universe can lack a middle. None of this requires poetic exaggeration. It only requires patience with frameworks that are not built for intuition's comfort. General relativity deserves special attention in this shift, not as an abstract monument, but as the theory that changed what could even count as a sensible cosmic picture. Before Einstein, space and time were often treated, especially in Newtonian thought, as fixed backgrounds. Things moved within them. Forces acted across them. They were the arena.
Einstein's theory transformed the arena into part of the drama. Massive objects tell space-time how to curve. Curved space-time tells matter and light how to move. That slogan is simplified, but it captures the mutual relation. Once geometry itself becomes dynamic, the possibility of an expanding universe ceases to be a verbal contradiction and becomes a natural class of solutions. In fact, Einstein initially resisted the implication that his equations favored a dynamic cosmos. He introduced the cosmological constant in part to support a static universe, which was then the prevailing expectation. Later observations and theoretical developments changed the picture. The universe is not static, it expands. The equations allowed it. The sky confirmed it. That historical episode is revealing. Even one of the greatest physicists struggled against the idea that the universe might not conform to inherited intuition. The demand for stability, for a fixed cosmic order, for a kind of built-in permanence ran deep.
The loss of a center belongs to that same broader wound to common sense. Not only is the universe not centered where expected, it is not even standing still in the old way. The cosmological constant itself later returned in a new role as part of the explanation for accelerated expansion, often associated with dark energy. This is another reminder that the universe can force revisions at scales where ordinary imagery breaks down. Space not only expands, the expansion's rate has a complex history shaped by radiation, matter, and whatever dark energy ultimately is. Yet none of these refinements reintroduce a central launch point. They deepen the dynamic picture rather than replacing it. The loss of a center becomes even more conceptually rich when one asks how a center would be defined in an infinite universe. Suppose space extends forever and is roughly homogeneous on the largest scales. Where would the center be? Any point chosen would be arbitrary. There is no outer boundary from which a middle could be measured. Infinity does not come with a bullseye. This is not merely hard to calculate, it is empty as a request. An infinite Euclidean line has no central point, neither does an infinite homogeneous plane. A three-dimensional universe of that kind would likewise have no preferred middle. Every location has infinitely much universe in every direction. Any claim that one point is truly central would need a reason that homogeneity forbids. Finite but unbounded models reach the same practical conclusion by a different road. If space curves back on itself, there may be a total finite volume while still offering no edge and no internal central point. Again, the familiar relation among boundary, center, and scale breaks apart. This is where geometry starts to feel less like measurement and more like therapy for intuition. It teaches that some habits of thought were shaped by a narrow band of experience and cannot be trusted at cosmic scales. A room has walls, a box has a middle, a loaf has an interior. The universe may resemble none of them.
There is also a subtle linguistic trap in the word universe itself. It sounds singular and object-like, as though it should function grammatically like house or apple. One house, one center. One apple, one core. One universe, one middle. Language nudges the mind toward a shape long before physics intervenes. But grammar is not geometry. Calling something one thing does not mean it behaves like a bounded object. The universe is the totality of physical existence available to the model, not necessarily an object among objects. Once that difference is felt, many old expectations start to loosen at once. Still, there is a legitimate question hiding underneath the failed one. When people ask for the center of the universe, they are often really asking for orientation.
They want to know how the whole is arranged. If there is no middle, what kind of order replaces it? What does the universe have instead of a center? The answer is not nothing. The answer is structure without privilege of place. The universe has large-scale laws. It has a history of thermal evolution. It has expansion. It has curvature properties. It has content, ordinary matter, dark matter, radiation, dark energy. It has fluctuations imprinted in the early universe that later grew into galaxies and clusters. It has causal horizons. It has symmetries, broken symmetries, and measurable statistical regularities. These are not the same as having a middle, but they are forms of order far more informative than a central point would have been. In a sense, the universe replaces the architecture of centered objects with the architecture of relations. What counts is not distance from a hidden throne, but how regions relate through geometry, expansion, gravity, and time.
Time, in fact, almost sneaks a new kind of centrality back into the picture. If the Big Bang is not a place, perhaps it is at least the central time from which all later cosmic history unfolds. That idea is closer to the truth, though it too must be handled carefully. In standard cosmology, there is indeed a meaningful cosmic time for co-moving observers, a way of slicing the universe such that the hot, dense early phase stands as a common past state. The Big Bang is therefore much more naturally understood as a temporal boundary or early condition than as a spatial location. This is one reason old intuitions go wrong. They translate a question about time into a question about place. Where did it all begin sounds natural, but in cosmology, the more precise question is often, what was the universe like in its earliest known phase? The difference seems small in wording and enormous in consequence.
A beginning in time is not the same as a center in space. Once separated, the confusion becomes easier to manage. The universe may have a finite age in the sense that the hot Big Bang phase occurred a finite time ago, yet that does not imply any central location now floating somewhere in space like the cooled remains of an original ignition point. The past is not stored as a place. This is familiar in ordinary life too, though it is rarely noticed. Childhood is not somewhere on a map. It belongs to time, not space. The analogy is imperfect, but the general lesson holds.
Not every origin is a location. Then there is the question of edges. People often pair center and edge together, assuming that if one exists, the other must as well. A sphere has both a center and a boundary surface. A disk has a middle and a rim.
So, if the universe has no center, does it at least have an edge? And if it has no edge, how can that be reconciled with any kind of finiteness? Again, geometry provides the escape route. The surface of Earth is finite, yet lacks an edge in the ordinary sense. Travel far enough east, and the journey continues without falling off a side. The absence of an edge does not make the planet's surface infinite. It means the geometry closes on itself. Something similar could hold for cosmic space, though in 3 dimensions, and perhaps with more subtle topology than a simple analogy suggests. Even in an infinite universe, the absence of an edge is conceptually straightforward. What has no boundary does not need one. Infinity simply continues. The challenge then is not picturing an edge, but picturing endlessness without drifting towards some hidden central reference. Yet, if the space is homogeneous, every region is equivalent in the relevant large-scale sense.
There is nowhere for a center to latch on. The more these options are considered, the more it becomes clear that center and edge were never guaranteed concepts. They belong to some geometries and not others. The universe does not owe them to intuition. This recognition changed human self-understanding as much as it changed physics. The older, centered cosmos was not just a map of the heavens, it was a metaphysical comfort. A center suggests significance. To be near it is to matter in a spatially encoded way. Even after Earth lost that role, the longing for cosmic centrality remained in subtler forms. Perhaps the galaxy center, perhaps the origin point of the Big Bang, perhaps some grand axis through the universe. Cosmology kept refusing. That refusal does not humiliate humanity unless significance depends on occupying a privileged coordinate. The deeper shift is more mature than humiliation.
It asks whether meaning was ever something that should have been expected from location alone. The universe may not assign importance by geometry. Value, purpose, awareness, culture, memory, love, loss, knowledge, none of these are guaranteed or denied by being central in space. Yet the emotional force of the old center should not be dismissed. Losing it was historically destabilizing. A centered universe is easier to narrate. It aligns with power, ritual, direction. It reassures the imagination that reality is laid out around a comprehensible core. A universe without a center is quieter, colder to some temperaments, but also cleaner. It asks for a different kind of awe, one that does not rely on being chosen. This shift from chosenness to participation may be one of cosmology's lasting gifts. There is no evidence that any ordinary place is where the universe wanted to happen most.
Instead, every region participates in the same broad laws. Every observer in the Hubble flow can read expansion from the sky. Every patch of matter shares the same deep ancestry in stellar furnaces and primordial plasma. The loss of the center is accompanied by a gain in universality. A useful way to feel this is to imagine the early universe not as a single fireball in a void, but as a nearly uniform hot sea of plasma extending far beyond any current observational horizon. Tiny fluctuations ripple through it. Over immense stretches of time, those fluctuations grow under gravity into the galaxies and clusters now seen. No one point in that sea is the secret birthplace of all others. The whole sea is the birthplace. That phrase comes closer than many popular descriptions.
The whole sea is the birthplace.
And still, even that can mislead if imagined too concretely, since the earliest moments are not directly visible, and the standard model cannot simply be extended backward forever without eventually meeting regimes where quantum gravity becomes relevant. There is honest ignorance there. The singularity, often drawn at the beginning of textbook diagrams, marks not a fully understood physical event, but a sign that classical general relativity reaches a limit. Yet again, the unknown does not revive a center. It marks a boundary of current theory, not evidence for a privileged place. There is another subtlety worth preserving. When cosmologists say the universe is homogeneous and isotropic on large scales, they are not claiming this as an exact fact down to every detail. The universe contains structure. Galaxies cluster hierarchically. Vast cosmic voids interrupt the distribution. There are huge filaments and walls spanning hundreds of millions of light years.
But beyond a certain scale, these irregularities average out enough for the broad statistical symmetries to emerge. This is exactly what allows the centerless model to work. Uniformity is not perfect sameness. It is sameness in the right averaged sense. Local observers can therefore inhabit very non-central looking neighborhoods without undermining the deeper claim. The local group, the Virgo cluster, the Laniakea supercluster, these are all structures with particular arrangements. None provide a hidden global middle. They are like eddies in a river, not proof of a cosmic throne. The same restraint applies to directional oddities occasionally discussed in cosmology, such as anomalies in the cosmic microwave background or debated large-scale patterns that tempt headlines about cosmic axes. Such topics are scientifically interesting and sometimes provocative, but none has overturned the broad picture of no observed central location or no established preferred place in standard cosmology. Extraordinary claims here demand extraordinary evidence, and so far, the centerless, homogeneous large-scale model remains the best supported framework.
That does not make it easy to visualize. In fact, one of the most honest things that can be said is that the universe may not be fully picturable in ordinary human terms. Visualization is a tool built from evolved life on one planet at one scale. Mathematics can outrun it. Concepts can remain clear, even where pictures become unreliable. This is not surrender, it is maturity. Not every truth wears a familiar image. The goal, then, is not to force a perfect picture, but to avoid the wrong one. Better an incomplete but accurate understanding than a vivid false image of a cosmic bomb exploding into darkness from a central point. Better to know which analogies are safe and where they fail than to cling to cinematic intuition. The balloon analogy fails when it invites the question of the balloon's center, as though that were physically the universe's center. It fails when it suggests space must be expanding into something external. It fails when the rubber surface is taken literally rather than geometrically.
The raisin bread analogy fails when it suggests galaxies themselves swell with expansion, or when the dough is imagined as a physical substance filling all of space in a mechanical way. It fails when local gravitational decoupling is ignored, or when the oven becomes a metaphorical outside. The grid on rubber sheet analogy fails when it implies two-dimensional embedding is essential. It also fails when space-time is treated like an actual material sheet that could wrinkle in a room. These failures are not reasons to discard the analogies, only reminders that analogies are bridges, not destinations. A good analogy removes one false intuition. A bad reading of it can introduce another. This discipline of using and then discarding imagery is part of what makes cosmology feel so unusual. The mind must repeatedly accept partial help while refusing total seduction by the image. It must step across the bridge and leave it behind.
And after enough of these crossings, the central idea begins to feel less impossible. The universe does not need a center. Expansion does not require a central launch site. The Big Bang was not a detonation in space. Every observer can see recession without being privileged. The observable universe is centered on the observer without granting that observer cosmic status. The full universe may be finite or infinite, but either way, a special middle is not required. These claims, taken together, form one of the cleanest breaks between common sense and modern physics. There is a final source of resistance, and it has less to do with science than with existential imagination. People often want the universe to have a center, in the way they want a tale to have a protagonist, or a city to have a square. The center promises orientation. It tells the imagination where to stand. A centerless universe can feel emotionally blank, as though it offers no guidance on how to place the self.
But perhaps that feeling comes from looking for the wrong kind of orientation. Cosmology is not a manual for assigning worth by coordinate. It does something stranger, and in some ways more generous. It reveals that local experience of centrality is universal, not exclusive. Every conscious being, if such beings are scattered through the cosmos, inhabits a world that opens outward from where they stand. Each sees horizons. Each sees the sky arranged around their line of sight. Each could be tempted to mistake that for privilege. Each would be wrong in the same enlightening way. The structure of reality allows every observer a centered view without granting any observer a centered universe. There is something almost ethical in that arrangement. It honors perspective without turning perspective into dominance. And perhaps that is why the idea lingers so strongly once understood. It does more than solve a geometric puzzle. It reframes the relation between appearance and truth, between local experience and universal law.
Consider for a moment the alternative. Suppose the universe did have a center in the old intuitive sense. Then space would be organized around a privileged location. Expansion would carry a directional logic away from that origin. Observers in different places would not be equivalent in the deep way modern cosmology suggests. The sky itself would encode hierarchy. Reality would have a capital. Instead, the evidence points toward a universe whose grand order is not centralized. Its coherence arises from shared laws and common history, not from nearness to a master coordinate. That is not disorder. It is a different form of order than the human imagination first anticipated. The philosophical consequences continue unfolding. A centerless universe weakens the notion that spatial position alone can reveal metaphysical status. It supports a vision in which laws are local yet universal, in which no ordinary place is the place. It invites humility but not despair, wonder but not fantasy, clarity but not simplification. It reminds thought that the cosmos is not obligated to echo the architecture of villages and palaces. There are still centers in the universe, but they are provincial. The center of a star, the center of a planet, the center of a galaxy, the center of mass of a cluster. Rich, real, measurable. Yet all of them are local features nested inside a reality that, on the largest scales, withholds the one center common sense most desires. This withholding is not a cruelty of nature. It is a clue about scale. Concepts built for finite objects fail when asked to govern totality. The universe is not merely a bigger thing, it is a different kind of thing to think about.
That may be the deepest lesson of all. There is one more angle from which the disappearance of the center becomes especially vivid. Imagine winding the cosmic expansion backward. Galaxies draw nearer, temperatures rise, matter and radiation become denser. Structures dissolve into earlier forms. Yet no matter how far the model is run back, the universe is not seen collapsing into a dot sitting at some particular address in space. Instead, all co-moving distances shrink. The entire large-scale fabric approaches a hotter, denser state. The past is global. That is why phrases like "where the Big Bang happened" are almost always trouble. They use a spatial form for something better understood as a temporal condition. The Big Bang happened not somewhere, but some when. And even that answer becomes delicate near the limits of the theory. What remains solid is that no observational evidence points to a preserved center of origin in space.
A similar caution applies to before the Big Bang. Perhaps there is a meaningful answer in some future or speculative theory. Perhaps there was a prior phase, a bounce, a quantum regime, and eternal inflating background, something else entirely. But whatever the answer turns out to be, it would not automatically convert the Big Bang into an explosion from a point inside ordinary space. Better theories may extend the picture. They need not restore the discarded intuition. So the universe remains strange in a very specific way. It lacks not merely an answer, but the kind of answer intuition keeps demanding.
That absence is easy to state and difficult to believe. The night sky does not announce it in plain language. Telescopes show galaxies, not philosophical corrections. The correction emerges from patient synthesis, redshifts, background radiation, general relativity, large-scale surveys, careful definitions. Only then does the old image finally give way. And when it does, the universe can feel at once more impersonal and more intimate. More impersonal, since no hidden stage was reserved for one place above others. More intimate, since the laws shaping the largest structures are present even here, in the same expanding cosmos, under the same ancient sky, whose light has crossed billions of years to arrive. The loss of the cosmic middle does not exile anyone from reality. It places every observer inside a universe whose order is shared rather than centered. That is a subtler kind of belonging. There is also an aesthetic shift embedded in this idea. Centered systems often feel classical, architectural, composed around symmetry and command. A centerless cosmos feels more like music distributed through space, pattern without throne, order without a focal monarch. That comparison should not be pushed too far, but it catches a mood the equations themselves do not express. Modern cosmology replaced the image of the universe as a built monument with something more fluid, an evolving large-scale geometry carrying matter, radiation, and time. Not a temple with a sanctuary, a dynamic whole with no privileged room. Even now, though, one final question often survives. If every point can regard itself as central in observation, is the idea of center simply meaningless? Not entirely. It still functions perfectly well inside bounded systems and within specific geometries.
What disappears is the assumption that the whole universe must instantiate that notion in the same way. The concept is not abolished. Its jurisdiction is reduced. That reduction is characteristic of science at its best. Old concepts are not always destroyed. They are delimited. Up still works near Earth, though not as an absolute universal direction. Solid works in daily life, though matter is mostly empty space at atomic scales. Now works locally, though relativity complicates universal simultaneity. Center works for many things,
though perhaps not for the universe as a whole. These are not defeats of understanding. They are refinements. The deeper order revealed by cosmology is not less beautiful for lacking a center. If anything, its beauty lies partly in the way it escapes inherited theatrical expectations. The universe does not arrange itself around a place where the camera should stand. There is no universal front row. Each location is local. Each horizon is partial.
Each observer is ordinary in the large-scale sense, and unique in the experiential sense. The cosmos is wide enough for both truths. Perhaps that is why the question endures. Where is the center of the universe is not only a scientific query, it is a human reflex. It asks whether reality has a middle in the same way the self feels to inhabit one. It asks whether totality can be oriented the way a room can. Cosmology answers with a kind of disciplined mercy. It does not mock the question. It explains why the question arose, why it works so well in smaller worlds, and why it fails here. The failure is illuminating. It reveals that the universe is not an object resting in a larger room. It reveals that the observable universe is a horizon-centered view, not a cosmic throne room. It reveals that the Big Bang is an early state of everything, not a blast from one point. It reveals that expansion is geometric, not ballistic.
It reveals that finiteness does not entail an edge, and endlessness does not entail a middle. And above all, it reveals a boundary where common sense reaches its limit. That is the real place at the heart of this topic. Not a spatial center, but a conceptual one. A threshold where ordinary categories stop working and a more careful language has to take over. This threshold changed science, but it also changed imagination. Once the universe ceased to have a privileged center, human beings had to find new grounds for significance. Some resisted. Some turned the loss into existential bleakness. Others treated it as liberation, a release from grand hierarchies of place, a chance to belong to reality without claiming to own its middle. Either response says something about human need, not about the geometry of space-time.
The geometry remains what it is. Galaxies recede on the largest scales. The cosmic microwave background surrounds every observer. The observable universe centers on whoever is looking. No measured coordinate identifies a universal middle. The early universe was hot and dense everywhere in the modeled region. Space can evolve without expanding into a larger ordinary container. These are among the cleanest truths modern cosmology has assembled. Of course, future physics may deepen or modify the framework. Quantum gravity may recast the earliest moments. New observations may sharpen global curvature bounds, constrain topology more tightly, or reveal surprises. The universe is under no obligation to stop being stranger than current theories. But whatever comes next will still have to explain why the present evidence so strongly supports a cosmos without a special central place. Any better theory will not earn its place by reviving simple intuition.
It will earn it by explaining more with equal or greater precision. That is worth remembering whenever old images return. Intuition is not an enemy. It is a starting point. It guides thought through medium-sized reality remarkably well. But when it collides with the deep universe, science advances by honoring intuition's usefulness while refusing its authority beyond its proper range. The center of the universe belongs to that category of once natural ideas whose power came from local success. Almost everything encountered in life taught the mind to expect a middle. Cosmology had to teach otherwise, and it did, not by clever paradox, but by patient accumulation. By watching galaxies redshift, mapping the microwave afterglow,
following the logic of relativity, distinguishing visible horizon from total reality, and learning that scale changes what questions mean. That long correction may be one of the great achievements of modern thought. It did not merely move humanity from the center. It dissolved the center itself as a feature the universe needed to possess. The shift is easy to underestimate now, partly due to familiarity, but its strangeness remains intact. The place common sense most expects to exist is not hidden in the dark. It is not at the edge of observation. It is not behind a brighter galaxy or beyond a farther one. It is not there. And that absence leaves the universe more open, not less. Open in the sense that no location monopolizes the view, that the same large-scale law holds across immense reaches, that every observer stands at the center of what can be seen, while remaining one local witness among many. And open in the sense that reality may be finite without a border, or endless without a middle. The result is not emptiness of meaning. It is a more demanding kind of meaning, one that cannot be borrowed from a spatial privilege.
It must come from understanding, participation, relation, and the sheer fact that consciousness can arise inside a universe subtle enough to have no center and still be known. For all the violence suggested by the phrase Big Bang, the deeper picture is strangely calm. No cosmic grenade thrown into darkness, no central blast scar, no outward stampede from a primal room. Instead, an evolving geometry, ancient light, cooling plasma, growing structure, widening distance, and a lawfulness broad enough to let every galaxy watch the rest drift away. That calmness is one reason the truth feels more profound than the myth it replaces. A universe with a center would be easier to picture. A universe without one is harder to forget. Near the end of this thought, the original question changes shape. It no longer asks, where is the center? It asks, why was the mind so certain there had to be one?
The answer reaches back to rooms and stones and bodies and maps, to every bounded thing that trained perception to think wholes must gather around middles. Cosmology does not ridicule that training. It simply marks the scale where it expires. And at that scale, the universe becomes more than large. It becomes conceptually foreign, not hostile, not incomprehensible, just free from the architecture of ordinary expectation. That freedom is one of its deepest wonders. These boundaries are where the universe stops behaving like a bigger version of familiar things and starts becoming itself. There is another reason the idea of a cosmic center refuses to disappear. It is not only that ordinary objects have middles, it is also that maps do. Every map ever held in human hands has trained the eye in a particular way. There is always some relation between edge, scale, and center. A map may place home in the middle out of pride. It may place north at the top out of convention.
It may distort size, direction, or distance. Yet, no matter how the map is drawn, the page itself creates a silent promise. The world being shown can be arranged before the viewer. It can be stood outside. It can be framed. It can be turned into an object of sight. Cosmology breaks that promise. The universe is not available in that way. There is no ordinary vantage beyond it from which the full arrangement can be surveyed like a chart pinned to a wall. Every image of the universe is made from within the universe. Every measurement arrives from one embedded location. Every map of the sky is a local construction, even when it reaches across billions of light years. That may sound like a technical limitation. It is more than that. It changes the very kind of picture that can honestly be formed.
A map of a city can be checked against the city from an airplane. A map of a continent can be checked from orbit.
A map of the Earth can be checked from deep space, but a map of the universe has no such external court of appeal. There is no balcony beyond totality from which the draft can be compared with the real thing. And once that is understood, the hunger for a center starts to look like a hunger for a viewing platform that reality does not provide. That hunger is easy to sympathize with. It comes from a very old impulse. If something is real, then surely it must be possible, at least in principle, to stand outside it and point towards its middle. Yet the universe is not a mountain, not a city, not a planet. It is not one item among surrounding items. It is the full physical setting in which all such comparisons take place. The imagined outside observer keeps slipping into thought, but the role itself may have no physical meaning. This is one of the quiet revolutions in modern cosmology.
The universe must be described from the inside. That sounds simple until the weight of it lands. To describe something from the inside is to give up certain comforts. It means perspective is unavoidable. It means horizons are built into the act of observation. It means the visible region is never the total region by default. It means every image of the whole carries traces of where it was made. It means words like edge, center, and shape need stricter handling than daily speech usually gives them. The difference can be felt by imagining an ant living on a vast curved surface. The ant can draw local maps. It can measure angles, trace paths, compare distances, and slowly infer the geometry of its world. Yet the ant's understanding does not begin with an overhead image of the full surface. It begins with neighborhoods, then wider neighborhoods, then patterns extracted from travel and measurement.
The final insight, if it comes, is not a scenic view from outside. It is a reconstruction from within that is closer to the human condition in cosmology. The universe has been understood by collecting local clues and letting them build toward a global picture. The redshift of galaxies, the near uniformity of the cosmic microwave background, the distribution of large-scale structure, the success of relativistic models, the abundance of light elements, the history of cosmic expansion, these are interior clues. None comes from stepping out of the universe and looking back. The entire modern picture is an inside reading of an all-enclosing reality. And perhaps that is why the absence of a center feels so difficult. A center is often easiest to imagine from outside. A circle drawn on paper has a center visible at a glance. A sphere held in the hand has a middle that can be pictured. The center is often a viewer's concept before it is a participant's one. Cosmology removes the viewer's privilege and leaves only the participant's evidence. From within the universe, no unique middle appears. This becomes even more striking when the act of looking is pushed to its limit. Looking farther into space means looking farther into the past. That line is familiar, yet its consequences are easy to underplay. The deep sky is not a photograph of one cosmic moment spread across all directions. It is a layered archive. Nearby galaxies are seen at relatively recent stages. More distant ones are seen when the universe was younger. The farthest light accessible to present instruments comes from epochs unimaginably remote in time. In one sense, the sky is all around. In another, it is also all through history. That alone begins to loosen the idea of a spatial center. A centered object is usually pictured at one time. A ball can be sliced and measured now. A room can be entered now. A planet can be modeled now. But the universe seen in light is not a single now laid out in front of the eye. It is a depth of time wrapped around the observer.
The horizon of visibility is therefore not only spatial, it is historical. This means any simple picture of the universe as a thing with a visible core is immediately compromised. The sky does not present an inside view of a static object. It presents a time-structured field of information. At greater depths, the past itself becomes the scene. The cosmic microwave background is the most dramatic example. It is not a wall at the edge of space. It is radiation from a young universe that has been traveling ever since. Looking toward it is looking toward an early phase, not toward a surrounding shell built as a final boundary.
That distinction is crucial. A shell suggests enclosure. The microwave background does not enclose in that way. It marks the limit of what can be seen in electromagnetic light from that epoch. Another observer elsewhere would also be surrounded by such a view. Their ancient afterglow would not prove that they occupy the center of a giant sphere. It would only prove that they too live inside a universe with a hot, dense past and a finite speed of light. This is one of the most beautiful symmetries in cosmology. The deepest visible past wraps itself around every observer. The result can seem almost designed to confuse intuition. Every observer receives a sky that arrives centered on them. Every observer can trace the cosmos backward into earlier ages. Every observer can see the general recession of distant galaxies. All of it appears to flatter local perspective, and yet, taken correctly, it destroys the very privilege it seems to offer.
There is a profound lesson hidden in that structure. Reality can generate centered appearances universally without containing a unique center at all. That lesson reaches beyond cosmology. It touches the difference between a viewpoint and a status. A viewpoint is always local. It begins where the observer is. Status is a stronger claim. It says the observer stands in a specially favored position within the thing being observed. In daily life, those two can blur together. The world opens around the self, so the self feels central. Cosmology carefully separates them. The visible universe opens around the observer, yet the observer is not cosmically central in any deeper spatial sense. Once that separation is clear, many familiar confusions begin to dissolve. For example, there is the repeated claim that if all galaxies are moving away, then at least one galaxy must be closest to where it all began.
But this only follows if expansion is pictured the wrong way. In a blast, debris remembers an origin point in a static arena. In an expanding universe, the arena itself changes. There is no need for galaxies to be remnants flung through a pre-existing emptiness. The separation grows in the metric itself. Trace enough of that evolution backward, and one does not arrive at a surviving address in space. One arrives at a universe whose large-scale distances were once far smaller, temperatures far higher, and matter radiation conditions radically different. A common image sneaks in here even after the explosion picture has been abandoned. The mind begins to imagine the universe as a shrinking sphere if run backward. Not debris flying inward, perhaps, but a glowing ball contracting toward a point. Yet that picture still carries an outside view. It still turns the universe into an object in another space.
It still asks to be watched from beyond. Cosmology does not need that image, and in many ways it is better without it. A more honest thought is harder and cleaner. Run the expansion backward, and all large-scale separations reduce. The hot, dense phase is approached everywhere in the modeled region. The universe is not seen shrinking toward a location. It is seen approaching an earlier state. That single shift from location to state may be the key intellectual move in the whole topic. The universe has an early state. It does not have an observed birthplace in space. That distinction also explains why the phrase, "the Big Bang happened everywhere," is not rhetorical decoration. It is a compressed statement about the nature of the model. Every region now participating in the large-scale cosmic flow was once in that hot, dense phase.
No one region can claim to have stood nearer to it in the sense that a suburb stands nearer to a city center. The early universe was not arranged like that, and yet none of this makes the universe vague. On the contrary, the large-scale picture becomes more precise once these old visual habits are cut away. The expansion rate can be measured. The age of the universe can be estimated within the Standard Model. The relative abundance of hydrogen, helium, and lithium can be compared with predictions from primordial nucleosynthesis. Tiny fluctuations in the microwave background can be analyzed and linked to the later growth of structure. Dark matter and dark energy remain mysterious in their nature, but their gravitational and dynamical roles are constrained. Precision enters not through finding a center, but through understanding patterns that do not require one.
This is an important correction to the fear that losing the center somehow makes the universe less knowable. It does not. A center might have been emotionally satisfying, but it is not what made cosmology scientific. What made cosmology scientific was the discovery that the universe is lawful on large scales, and that those laws can be tested against observation. In a strange way, the absence of a center is part of that lawfulness. If one spot in the universe were truly privileged in the old sense, the sky would have to reveal that privilege somehow. Large-scale observations would carry a directional or locational bias anchored to it. The cosmos would look different in a way tied to that status. Instead, the broad evidence supports a universe whose large-scale behavior is astonishingly democratic. Typical observers in typical regions can expect the same governing pattern. No obvious special place, no preferred direction on average, no visible throne around which totality is arranged.
That democratic character is not sentimental, it is structural. It also changes how scale itself is imagined. In everyday life, large size tends to mean a farther edge and a more remote middle. A bigger stadium still has a center circle. A larger nation still has an interior. A wider ocean still lies within a globe. Magnitude alone does not remove centrality. But in cosmology, increasing scale eventually changes category. The universe is not just a larger bounded thing. It is a setting whose overall geometry may not admit the kind of center finite objects usually possess. That leap from larger object to different category is where many people lose their footing. It feels like evasion, yet science has forced similar moves before. A gas is not just a crowd of tiny pebbles in the sense intuition first imagines. Light is not merely a stream of miniature bullets, nor merely a classical wave in the old medium-bound sense.
Time, in relativity, is not just a universal river flowing identically for all observers. Again and again, deeper physics replaces enlarged common sense with a framework that behaves differently at its roots. The centerless universe belongs to that tradition. There is another expansion of the idea that deserves space. If no center exists, then where are we becomes a subtler question than it first seems. In local astronomy, the question has many excellent answers. Earth orbits the Sun. The Sun is one star in the Milky Way. The Milky Way sits within the local group. The local group lies near the Virgo cluster and inside larger structures that belong to the cosmic web. These nested answers are rich and meaningful. They locate the observer within concrete systems, but none of them lead upward to a final cosmic center. The chain of nested location does not culminate in a master coordinate. It culminates in a framework where location remains relational and local. This can be unsettling at first, since human thought often wants the final map pin. It wants the last answer to where are we really? Yet perhaps that expectation already contains the old mistake. Perhaps there is no final pin of that kind to place. To know where something is may always mean to know where it is relative to some structure, some frame, some scale, some history. The universe offers many such structures, but not one supreme middle. That does not weaken location, it clarifies it. We are here remains perfectly meaningful inside the Milky Way, inside the local group, inside the observable universe. It only stops short of becoming, and here is the center of everything. The sentence fails at the final step. One of the most powerful ways to feel this is to imagine intelligent observers in another distant galaxy, one so far away that its light has taken billions of years to reach the Milky Way.
Suppose they have physics. Suppose they build telescopes and detect the redshift of galaxies. Suppose they map their own microwave background. Suppose they infer the same broad cosmological model. Their maps would center their own location. Their visible universe would stretch outward from their own sky. Their local structures would become the nested answer to where are we? And eventually they too would face the same vanishing point in thought. No final cosmic middle would appear above their local coordinates. This imagined symmetry is not decorative. It is the heart of the modern view. Any typical civilization, anywhere in the large-scale cosmic flow, would confront the same lesson if it read the evidence correctly. The universe does not keep one answer for one location and a different answer for another. It offers the same correction to all. That universality is one reason the idea feels so clean once it clicks.
The conclusion does not depend on Earth, on the Milky Way, or on any one region having special access. It arises from the structure of cosmology itself. And still, the mind may ask, if space can be finite and unbounded, or infinite and homogeneous, how can that ever be more than mathematics? How can something so unlike ordinary intuition count as real? The answer is that reality is not judged by resemblance to local habit. It is judged by whether the model explains and predicts what the universe actually does. If a curved or topologically subtle spacetime describes observations better than the old object in a box picture, then the strangeness is not a defect. It is a clue that intuition was trained on too small a world. This is worth dwelling on. Human common sense evolved among trees, predators, thrown stones, nearby hills, moving water, day and night, social groups, shelter, and seasonal sky. It is excellent for those scales.
It was never built to navigate expanding space-time, particle horizons, relativistic geometry, or the thermal history of the cosmos. There is no insult in that. There is only perspective. The universe is under no duty to be shaped for nervous systems raised on medium-sized survival problems. What is extraordinary is that such nervous systems can still learn to think beyond their original range. That achievement is not automatic. It requires language that knows its own traps. It requires analogy used with restraint. It requires mathematics where imagery fails. And it requires the patience to let the universe overturn ancient reflexes. The reflex toward a center may be one of the oldest. It is woven not only into geometry, but into culture. Human societies build ceremonial centers, political centers, trading centers, spiritual centers. The center often means legitimacy, power, orientation, belonging. A cosmos with no center, therefore, does more than alter astronomy. It quietly challenges one of the persistent symbolic habits of civilization. Reality, it turns out, does not have to mirror the arrangement of kingdoms. This does not mean the universe is chaotic or formless. Far from it.
Its large-scale order may be even grander for being non-central. The cosmic web, with its filaments, clusters, and immense voids, is not random spray. It is structure grown from initial fluctuations under gravity across billions of years. It is patterned without being centralized. That phrase captures something important: patterned without being centralized. Modern thought increasingly recognizes that many forms of order do not depend on a single controlling point. Weather systems, ecosystems, languages, markets, neural activity, and even some kinds of social organization can exhibit coherent, large-scale behavior without a solitary physical center that dictates every detail. Cosmology extends that realization to the largest stage of all. The universe can possess deep regularities without arranging them around one spatial core.
That idea also protects cosmology from a very old temptation, the temptation to convert ignorance into location. When a phenomenon is not understood, the mind often asks where the answer is hidden. Where is the engine? Where is the chamber? Where is the hidden room from which all this is governed? Such questions work well when dealing with machines, cities, bodies, or buildings. They fail when applied too quickly to totality. The universe may not owe an engine room to thought. Instead, it offers laws distributed through all accessible regions. Gravity does not operate from a palace. Expansion does not radiate from a cosmic furnace. The early hot, dense universe was not stored in one vault. The lawful behavior is everywhere, or at least everywhere the current model responsibly describes.
This is part of why the idea changes human self-understanding so deeply. It suggests that reality's order is not concentrated where one might kneel before it. It is immanent in the structure of space-time itself, not hidden at the center, but written through the whole. And that changes awe. It moves awe from pilgrimage toward understanding. There is no road to the center of the universe. There is only a growing ability to recognize that no such road is needed. Once that is absorbed, the old question almost begins to sound nostalgic. Where is the center becomes less a scientific demand than a trace of a former way of imagining the world. It is the last echo of treating the universe as a giant object that could, in principle, be set down before an observer. Cosmology does not answer that echo with contempt. It answers with a better framework.
No center in the observable evidence. No center made necessary by order. The result is not emptiness. It is a reality whose deepest coherence does not gather around a point. And perhaps the most powerful extension of that thought is this: the universe does not become less mysterious once the center disappears. It becomes mysterious in a more disciplined way. The mystery is no longer where is the hidden middle. It is what kind of totality behaves like this at all? What kind of reality allows every observer a centered horizon without granting any observer the central place? What kind of geometry can expand everywhere without expanding from somewhere? What kind of beginning is temporal and global rather than spatial and local? Those are harder questions than the original one. They are also better. The true strangeness of cosmology is not that it hides the center well.
It is that the universe seems under no obligation to contain the thing intuition spent so long demanding. That is not a small revision. It is one of the cleanest examples of reality refusing an idea that once felt unavoidable. And so the picture grows sharper. The universe is not a sphere viewed from outside. The night sky is not evidence of sitting near a hidden core. The observable universe is not the whole universe. The Big Bang is not a blast from one point into a waiting void. Expansion is not flight away from a surviving center. Large-scale order does not require a throne room. What remains is stranger, and in a deeper sense, more elegant. A universe whose geometry, history, and visibility conspire to make local centrality feel universal, while withholding any cosmic middle that would turn that feeling into fact.
That is the conceptual boundary this topic keeps circling. It is not merely about astronomy. It is about the point where an intuition that works almost everywhere in human life reaches its limit. The center belongs to rooms, wheels, stones, planets, stars, cities, galaxies, many finite systems. Then scale rises, geometry changes, and the old idea falls away. Not every thought survives contact with the whole. This one does not. And that may be one of the clearest signs that the universe is real in the strongest sense. It is not built to satisfy expectation. It is built, if that word can even be used, according to principles that had to be discovered rather than guessed. It had to be read from light, motion, temperature, structure, and the patient logic of physical law. Only then did the old demand for a middle finally lost its authority.
So, the lingering thought is not that the universe is missing something. It is that one of the places most expected to exist was never required in the first place. No hidden midpoint waits in the dark. No silent coordinate anchors the whole. The sky does not spread from a throne. The beginning was not a place. The expansion is not away from a center. And the most unsettling part is also the most beautiful. From wherever the universe is seen, it offers the same temptation to believe otherwise. Each horizon arrives centered on the observer. Each observer feels local centrality. And all of them, taken together, point toward the same conclusion. The universe does not have the place intuition asks for. Not lost, not concealed, not far away, absent. So, the place the universe does not have is not hidden from us. It is absent in a deeper sense than that. And understanding that absence may bring us closer to reality than any imagined location ever could. Subscribe to our channel for more explorations of the universe's strangest boundaries, limits, and ideas. Because the deeper we look, the less the cosmos resembles the picture we began with. Thanks for watching. See you on the next one.